Greetings everyone. So today you're going to learn about how to make write to hard drive and execute shellcode. This is great for malware that needs to be non-volatile. That means that after the computer shuts down, the malware stays on the hard drive, opposed to being a write to memory and execute, which would be removed or deleted as soon as the system reboots. So to do this, we start with Rmutate. Just want to show you the basics of the help queries. The Rmutate type help for basic queries. So we do that. This is going to be an input-output modification. So we're going to do Rmutate type help type parse. And here we got the create, write, and execute. So that create syscall is what that is for. And type it in. Here we've got the examples. So for right now, we can use this right here as the example that we're going to base this shellcode off of. And there. So Rmutate tag fx for file to hexadecimal, file to 6, or file to base 64s for the write to memory style, which we'll cover that in the next video. The file name, so we're going to use this proof of concept first. Windows.rb, tag platform OSX. This works for OSX and Linux. We'll get into Windows malware later on. Then the location of Ruby. So you could do which Ruby, type that into Rmutate R, and that will send it to our clipboard. Remove the last new line. So there we go, space, space. And then we put in the name that we want to name our file. So I'll just do r.rb. Or well, actually, we have to do the folder first. So temp, so let's do temp folder r.rb, close quote. And we need to have 2 spaces here to separate out the registers. So it's just like our last video. And for every argument we need a new register, so that's why we separated it out. And EX. We'll just start right off by looking at the shellcode, or the assembly code this time. So df folder, new folder, test, basic test. Great, and it executed. And let's see what this looks like here. So reload. So we have this open to file here, and that is the open syscall, which you can see the note here, which uses syscall 5, which is done right here. With OSX, we always have to move to over that and many bits. And then in this case, we wrote it to the temp folder r.rby, as you can see here. The write to file was, well, we already made the new open file. The write to file is where we say how many bytes. So we've got this many bytes. And then we need to get the content, so it's kind of like a decoder. So we're going to use the jump short shellcode, which is down here. This is our content. So if I were to copy this, it's in my clipboard. Made exit can be like an alias of Rmutate R. So we could do Rmutate hex to ASCII. And CB, this could be PP, which is also another global variable of clipboard CB. And just hit enter. You can see there's our shellcode for what the malware actually looks like. And we call the return shellcode here. So we land here, we pop it to our side, syscall. So it got the amount of bytes and then called it. And then we close open, and then we execute the file we just created. So here we are with the user local bin Ruby. and then the folder that we created, our Ruby file, which is hard.rb extension. And we push the arguments pointers to the stack. We make pointers push to the stack, and then we call it. And so that is, in a nutshell, how it works. Right? So, just to make this easy on myself, I'll literally just copy this exact command right here and traverse over to Linux. And the only thing I need to change is the platform. It didn't work. It's probably because the location of Ruby is different. So, Ruby. Yeah, that would explain it. Well, let's just do this. Be better probably. User bin env for environmental variable, 2 spaces, Ruby, because that's the next argument, the first argument of the env, and the first argument of Ruby, which is temp folder r.rb, which is a file we create, and these are still on a new register, so another 2 spaces. And there it executes. So let's take a look and see how this compares. Alright, so we create file this time, so it's syscall create instead of syscall open. You can do a man, for example, manual. And you can learn about how it works here. So, first, so syscall 55 permissions, make it executable. The name that we're gonna, the location in the name of the file. Then we're going to write to this file, so same thing, just like OSX, byte count. We're gonna, just like OSX, jump to grab our data, which is down here. And after we call this byte, or after we get those bytes, we're gonna call it. So, call return the shellcode, just kind of look at the coder, return the shellcode, we pop it, syscall. So we've written to it, then we close, create, post to open like OSX, and then just like the video previously on how we executed, we have these same dividers here. So user bin env, first argument, or the executable, first argument in this case Ruby, second argument is the name of the folder that we made, and then the name of the file, so r.rb. And then we push the pointers to the stack, or we make pointers and put them on the stack, and then we call it with the execve, the file we created, and that is that. So, and I mean, you can imagine any file you throw into it's going to be handled exactly the same way. So if we were to do something like ncat tech lvt 5555, right? And here we've got the reverse py, which is my variant on the Pentester Monkey version that is different because we use pty opposed to subprocess, which is much better in this case. We're going to change this RB to PY. And change the name of the file we want to convert. Alright, and it's going to execute. It's listening. And look, look at that, we've got a OSX reverse shell. Great. Cool. So that concludes Write to Hard Drive and Execute. I hope you enjoyed it and that you learned something. And in the next video, we'll continue with the shellcode development on Write to Memory and Execute. And in my opinion, it's a much better method. And mostly because it will save you bytes. It's faster. And because it doesn't write to the hard drive, it's harder for AV to pick up on it. Everything is run in memory. And then from what you have in memory, you can write to the hard drive just like you would in this code. Yeah, it's just it's kind of interesting to see how different types of assembly code work, and it will broaden your understanding of how computers run together. Great, thanks. I'll see you in the next video.